So, good morning, dear colleagues. I want to present you my study on transcranial alternating current stimulation of TCS after effects on cortical excitability measured by TMS-induced motor walk potentials. So, TCS is not the only technique for non-invasive brain stimulation. There are two main groups of non-invasive brain stimulation techniques called TMS, transcranial magnetic stimulation, and with it we can induce motor walk potentials if we apply it over primary motor cortex. And another group is transcranial electric stimulation. Transcranial electric stimulation is an umbrella term that includes different techniques for application of electrical current over the scalp, usually with two rather large sponge electrodes. The most studied is TDCS, transcranial direct current stimulation, and for TDCS it was shown robust both online and offline effects, especially if we apply stimulation over primary motor cortex. And TRNS and TACS has been studied less, but they have some potential advantages over TDCS, and it is very important to understand how they work. Okay, you can see on the graph that TACS become more and more popular during the last years. However, better understanding of its effects is needed to be applied in clinical purposes as a research tool in neuroscience and possibly for cognitive enhancement in healthy people. As well as for TDCS, TDCS is effective to modulate cortical excitability during stimulation. But in contrast to TDCS, offline effects or after effects are less rather mixed, and only in few studies not well controlled there were found some weak after effects of TDCS. And in this study, we decided to investigate in advanced neuronavigated sham-controlled TMS approach whether TCS can modulate cortical excitability during rest, after stimulation. And we expect to find no after effects after TCS is switched off. Because TCS entrainment seems to be online phenomenon. So experimental design. Experimental design is within subject. Each volunteer participated in 3 sessions, separated by at least 3 days. TCS conditions were randomized, and subjects and experimenter, me, were blind to the frequency of the stimulation. We recorded 2 blocks of motor walk potentials before TCS and 7 blocks after TCS, separated by 5 minutes. So our independent variable is frequency of TCS, 10 Hz, 20 Hz, or sham. Our dependent variable is average peak-to-peak amplitude of motor walk potentials after TCS. So we want to change how its dynamics of motor walk potentials amplitude before and after TCS application. We recorded data from 10 subjects, and we excluded 1 due to technical issues. We took participants with respect to current safety guidelines. We applied 1 milliamp TCS for 15 minutes. And active electrode was placed on the hotspot for FDI muscle, and reference electrode was placed on ipsilateral shoulder. And for sham we used TRNS for 30 seconds. Okay. And TMS procedure included finding hotspot for stimulation of FDI muscle and measurement threshold. And then we recorded these 2 blocks of motor work potentials and 7 blocks after TCS. Yeah, so it's not very okay. So we used navigation based on individual MRI scans obtained before the experiment. So let's go to results. Our first concern was blinding. Was it effective? And self-reported sensations didn't differ significantly, and also subjects made a guess after the whole experiment whether, as I think, they received active or placebo stimulation. And you can see that results are not very different across different sessions. So we can conclude that our blinding was successful. Let's go to our main results. So we conducted 3x7 repeated measures ANOVA, and both factors, condition and block, as well as their interactions, were not significant. You can see on the picture time course of MAPS amplitude respect to the baseline. So baseline is 100%, and you can see that it's not significant and not differ really high. And we also collapsed these 7 blocks, and we can see that difference from the baseline is random and not systematic, and it's in fact it's similar to the baseline. So we can conclude that that we found no after effects on cortical. We found no evidence that KCS remains effects on cortical excitability after switching off KCS stimulation. These results are valuable for understanding mechanism of KCS, and also they're very important for practical application, because it looks like some long-term effects shown for KCS based on some modified synaptic plasticity during TCS application, but not after. And thank you very much. Thanks to all people who helped me to conduct this experiment in the best way it was possible. And also thanks to all other people in our center, in our labs, because it's very hard to overestimate the fact that I was surrounded by very active and very motivated researchers, and it was very important for me. Thank you very much. And